Acids and bases have two different faces, two different personalities, and you gotta find.
What is a titration? A titration is a word used to describe an acid-base reaction where you know the concentration of one of your reactants, either the acid or the base, and you do not know the concentration of the other reactant, either the acid or the base. So basically, a titration is where you use a known concentration to solve for an unknown concentration. It's always a neutralization reaction where you are reacting an acid and a base to form a salt and water. Before we begin the titration, let's do an overview of the equipment that we'll be using for this lab. First of all, we need to be wearing goggles because we're working with acids and bases. The equipment that we're going to be using in this lab, some of it is labeled specifically for the use of a base, and some of it is labeled specifically for the use of an acid. When we label them, the acid equipment will be labeled with red tape, reminiscent of the fact that an acid turns litmus paper red, and the things that will be used for the base will be marked with blue tape, reminiscent of a base turning pH paper blue, okay, or litmus paper blue. Okay, let's start with the base. The base is what goes in the burette. You can see that the burette's labeled with blue tape. The word burette also starts with the letter B. Funny, okay. And I'm going to be filling this burette with my beaker of base. It's labeled in blue. I'm using the funnel at the top, and I'm making sure that at the bottom, the stopcock, this is the stopcock, it's what turns the burette on and turns the burette off. I'm making sure that the stopcock with the little handle is perpendicular. That means that base will not start to flow as I fill this up. Okay, I'm going to fill it up almost all the way to the top, but I am not going to fill it past the 0 milliliter line. Okay, because anything past the 0 milliliter line, I will not be able to measure. And I'm dripping base, which is not the end of the world. Okay, so I'm going to stop about right there. It's close to the 0, but it's not at the 0. Okay. Now, in order to prepare my burette, I need to make sure that the base is flowing properly and that there aren't any air bubbles trapped in the tip of the burette. Also, this tip of the burette is very fragile, okay? So we really need to be careful. These are expensive burettes, and even a little crack in the tip can be really just ruins the burette, okay? So the first thing I'm going to do is I'm going to just let this base run by turning the stopcock and making sure that there are no air bubbles and then there's a clear jet stream at the bottom of base, and there is. So my burette is good to go, okay? And I can just keep putting in base like that for the entire lab, okay? Now, the other equipment is used for the acid. The acid, first of all, is going to be put in a small beaker because we're not using a lot of acid labeled in red. We are now going to measure out exactly 10 milliliters of our acid that we will be titrating with a volumetric pipette. A volumetric pipette is a piece of glassware specifically designed to measure one volume and only that volume. We're going to be using a 10 milliliter pipette, and right at this brown line, that's when I know I have exactly 10 milliliters. This is much more accurate than a graduated cylinder. There's a lot of estimation involved in a graduated cylinder when I measure a volume with that. But when I use a volumetric pipette, I'm getting exactly whatever this volume measurement is. So we're going to have not just 10 milliliters, we're going to have 10.0 milliliters of acid, which for sig figs is it's a greater deal of certainty. Okay? When I measure the acid, I'm also going to be using a pipette pump. A pipette pump is what allows you to draw up the acid into the pipette, and you do so simply by placing your thumb on this wheel and scrolling up. Creates a low pressure system inside, and the atmospheric pressure outside pushes up the acid, and I will scroll up until, I passed the brown line, but that's not a problem because I can always scroll back down. And I will scroll back down until the bottom of the meniscus is touching the top of that brown line. I now know I have exactly 10.0 milliliters of acid. I will now place that acid in my 250 milliliter Erlenmeyer flask, and I will do that by pressing the button on the side of the pipette pump. I can also press this scroll down to get rid of the acid, and keep pressing this button, and it's going to release the acid into the Erlenmeyer flask. Now, there is always one drop, you can come in here, there's always sort of one drop left at the end of the pipette. That is part of the 10 milliliters, and we don't want to lose that. So we are going to rinse that into our flask with some distilled water. I can always rinse things with distilled water because distilled water is not changing the moles of the acid. It's just simply changing the volume. Okay? But I really care about the moles of the acid in this lab. Okay, so I've gotten rid of that last drop. I now have my acid in my Erlenmeyer flask, and I'm ready to go on to the next step. We have finished measuring the acid with the volumetric pipette, and we are done with it for this trial. So we are going to properly store it out of the way on the other side of the burette clamp. I simply pinch these two sides of the burette clamp, place the volumetric pipette in between, and allow it to stay there. Okay? Now I have my acid in my Erlenmeyer flask. I'm going to be adding base to it, but I need to know at what point have I reached neutralization? At what point have I reached a neutral pH of 7? And in order to do that, I have to have an acid-base indicator. The most common acid-base indicator that we use in titrations is an acid-base indicator called phenolphthalein. Phenolphthalein is an aqueous solution, and I'm going to add a scant 3 drops to my Erlenmeyer flask. If I can get this open. Okay. I'm just going to add 3 drops. And I'm going to swirl that flask. And you'll notice that nothing has happened. It looks exactly the same. That's because phenolphthalein is clear in the presence of an acid. It will not turn colors until I begin adding the base. It's clear in the presence of an acid. It's pink in the presence of a base. Before I begin adding the base to my flask that has my acid in it, I need to know what is the starting volume of the base in the burette. This is the most important measurement that you are going to make.
Go.
In order to make an accurate volume measurement in the burette, I need to look at the bottom of the meniscus. The best way to do that is to place an index card or a piece of paper with a black line on it to touch the bottom of the center of the meniscus. I will read from the bottom up, and I will use the correct number of significant figures. In this case, I know I have 8 milliliters. I know I have 8.5 milliliters. I'm going to estimate one more digit, and I'm going to estimate that this is 8.55 milliliters. I will record that in my data table. Every volume that I measure with this burette, I will have 2 digits after the decimal in order to have the correct number of significant figures. I am now ready to add base to my acid. The problem is I don't know how much to add. I don't know how much base will neutralize my acid. This is what we call the first trial, or a dry run. I'm simply going to add about 2 or 3 milliliters of base at a time and see what happens to the color of the solution in my flask. And I will just simply do that by turning the stopcock. I'm going to add about 3 milliliters. You can see that there is a pink color in this flask, but when I swirl it, that pink color disappears. That means that I still have an acid. I have not reached a base yet. Okay? And I will not reach a base until I have that pink color, and that pink color does not disappear. I'll know that I'm getting close to neutralization or close to the end point when the pink color starts to disappear much more slowly. Okay, so you can see that the pink color, and I actually have a white piece of paper underneath here. That's a good, you could see there that it's disappearing more slowly. And the white paper underneath here allows me to see exactly what kind of coloring is going on. Oh, and there I am swirling, and the pink color is not disappearing. I now have a basic solution. I have gone from an acid to a base. I have kind of overshot the end point. I've now finished my first trial, and this is a really bad pink color. This is really too dark. It means I've overshot the neutralization point, or what we call the end point of the titration. But that's okay for my first run, because now I'm going to be able to read the final volume, and I'll know roughly how much base I should add for my next trial. So let's read the final volume of the base. Very important. We're going to do it with correct sig figs once again. I know that the volume is 19. I also know it's 19.7. I'm going to estimate that it's 19.75 milliliters. That's what I'll record in my data table. Now that I'm done with my first trial, I need to prepare for my second trial. I'm going to rinse this down the drain with tap water, copious amounts of tap water, and then I will rinse out the flask once more with distilled water to prepare it for the second trial. Let's do that together. And once with distilled water. Okay, we have an Erlenmeyer flask that's ready to go for trial 2. I'm going to put 10 milliliters of acid in the flask once again using my pipette. I'm now ready to begin the second trial of my titration. I've added 10 milliliters with the volumetric pipette of the acid. I've added 3 drops of phenolphthalein once again, and I know the starting volume of the base in my burette because it's the ending volume of my previous trial, 19.75 milliliters. Now, in my first trial, I added 11.2 milliliters of base. That was the difference between the starting volume and the ending volume. What I'm going to do now is I'm going to be more careful. I'm going to add about 9 milliliters straight off the bat, and then I'm going to start to add it 1 drop at a time. Let's do that together. First, we'll add the 9 milliliters. So I'm starting at 19.75. We'll go down to about 29 milliliters, about 10. And we'll go down to about 28 milliliters. Okay, I'm swirling. Okay, I'm stopping it. I'm at about 28 milliliters. Okay, and you can already see that we're close to the end point because the pink color is not disappearing as quickly. Now I will begin to add the base drop by drop. And this is the hardest technique of a titration. The best way to do it is to turn the stopcock very, very slowly until you see a drop beginning to form at the end of your burette. You will let it fall. And then you will turn the stopcock. Now, do you see how there's a little bit of base that's left over at the end of the burette? I can't waste that base. That's technically part of the volume that I have added. So I am going to touch that drop to the side of the Erlenmeyer flask, and I am going to then rinse, and just rinse that drop along the side down into the Erlenmeyer flask and swirl. I will continue to add the base about 1 drop at a time until I get a light pink color that does not disappear. Okay. Oh my goodness. Oh my goodness, I had a light pink color, but you see upon swirling that it does disappear. I am very, very close to my endpoint. I probably only need to add about half a drop more. Now let me show you how to add half a drop. I will turn the stopcock very slowly, and I will not let that drop fall from the burette. I will just let it grow. It grew just a little bit. I will now add that with my distilled water, and I will swirl, and yet the pink color did disappear. I will continue to do this 1 drop or 1/2 a drop at a time until my pink color does not disappear. I'm going to add a full drop. I think I'm... And there I am. Okay, I have a pink color that does not disappear. It's not extremely light pink, so I could have done a little bit better. Maybe added a 1/2 a drop instead of a full drop in that previous step. But it's definitely a lighter pink than I had before. You're trying to get as light of a pink color as possible that does not disappear. This is how I know I am very close to that endpoint. I have just left the acidic state and I just transitioned into the basic state. The moles of my base have neutralized the moles of my acid. Okay? And I'm going to take my final volume reading. This is a really good trial. I'm definitely going to use this data. Now that I have the light pink color of the titration, I'm done with my trial. I am going to use the volume of my base and the volume of my acid to do a calculation to figure out the unknown concentration. One of them I know the concentration of, and I will use that to figure out the concentration of the unknown. So now that I've gotten my data, I'm able to do my calculations and solve for the unknown concentration.
Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Now the first thing you gotta get straight in your head: acids turn blue, litmus paper to red. They react with metals with awesome power. They neutralize bases and taste very sour. Bases are different from acids, it's true. Bases turn red, litmus paper to blue. They neutralize acids, feel slippery on skin. They taste sort of bitter, and they're called alkaline. Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Well, there's even more to this wonderful tale, something we call a pH scale. It numbers from 0 up to 14. Those are powers of 10, if you know what I mean. When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way. Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Well, acids and bases, now why should you care? 'Cause acids and bases are everywhere. You put them on salads and they get in the rain. They settle your tummy and clean out your drain. So the next time you're sitting under some shade and you're sipping a glass full of real lemonade, you'll notice the sour taste and think in your head, I bet it turns blue litmus paper to red. Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry.